Let's take a moment and look at OpenShift migration permutations. Where are customers moving from in terms of current state, and where are they going to in terms of future state? So for the vast majority of customers that I interact with, those customers start on premises or they start in a different environment, and many of them have an existing OpenShift investment. Some of these have been running OpenShift for a very long time, so they may be on an older version. They may end up on something like self-managed OpenShift container platform, or OCP, and this might be an older version such as OCP3. In this case, these customers, if they're moving into the cloud, if they're moving into an adoption cycle, they are unlikely to bring OpenShift 3 to AWS. So again, we're going to see two things happening here. We're going to see firstly a migration from where the customer is currently. This might be on premises, this might be a different environment such as a different cloud provider coming into AWS. They're not going to bring that OpenShift 3 investment to AWS. What's much more likely to manifest is that customer is going to come to AWS and they're going to bring OpenShift. It might still be self-managed, but it's going to move towards an OpenShift 4. For most customers, this transition depends on a couple of things. If there is a data center exit strategy, if there is a desire to disconnect from this environment, and there is a desire to do that before there is a hardware or a software refresh, normally we would see the customer prioritize lifting and shifting into AWS in its current state and then adapting or modernizing that workflow once they're on AWS. However, OpenShift 3 from an installer perspective and a lot of other things is not an ideal candidate. So even if we are seeing that disconnect from the previous environment, you're going to see a migration into AWS and you're going to see a migration from OpenShift 3 to OpenShift 4. Some of the customers I work with are not in a data center exit strategy. They're adopting AWS, they're adopting the cloud. A lot of their new data is here, a lot of their new development practices are here, a lot of the AWS services that they're interested in are providing value here, but they do still have a requirement to exist on premises. So they end up in that hybrid use case. That customer might make the move into AWS, they might move from OpenShift 3 to 4, but they very likely are going to do it both on premises as well as on AWS. The other thing that we see is over the last 2 years there's been a dramatic shift towards managed. Customers exploring, how do I move away from managing OpenShift myself? How do I refocus my resources on what's important to the business? And that tends to lead to exploration of a managed version of OpenShift. Very similar to other AWS services, we do the undifferentiated heavy lifting. Customer focus is what's important to them. As such, we have a managed version of OpenShift in the form of the Red Hat OpenShift service on AWS. This is also available in OpenShift 4. It's not an OpenShift 3 product. So if the customer's looking at adopting a managed version of OpenShift and they're running on OpenShift 3, they're going to be migrating to the cloud, they're going to be moving to a managed version, and they're going to be exploring, how do I move from OpenShift 3 to 4? Recently, new architectural shift. So if the customer is on AWS and they're an existing self-managed OpenShift customer, we could see a migration towards a managed version of OpenShift. So literally moving from OpenShift to OpenShift, but adopting a managed version. And then for some of our original OpenShift Classic or the standard version of ROSA, the managed version, we now have the Red Hat OpenShift service, ROSA with hosted control plane. HCP having an underlying architectural change where the control plane of OpenShift no longer exists in the customer's account. This behaves very much more like other AWS container services like ECS and EKS. So we're starting to see customers adopt hosted control planes as a more cost-effective approach. So we're starting to see that transition from a customer moving from ROSA to ROSA with hosted control planes. In a different space, we may see customers with investments of other application platforms. We may very likely see customers having an existing investment for Tanzu and potentially having a corporate high-level top-down mandate to move away from that to another investment like OpenShift. There are a variety of reasons why customers entertain moving from Tanzu to OpenShift, and we do see those migrations happen on premises, but we also see that take place on AWS. So customers who have an existing investment with Tanzu on AWS, exploring a shift towards OpenShift. With one subtle difference, we tend to see the adoption of that as a managed service again. So again, ROSA coming into the picture here. What we're seeing as a relatively new trend is customers who have adopted OpenShift as part of their broader modernization strategy, looking at ways of consolidating their virtualization stacks. So if we've got OpenShift as part of our modernization strategy, you may start seeing customers saying, there's a couple of virtual machines, I can't modernize those into a microservice or a container workload, but I'm going to consolidate those VMs and run them on top of something like OpenShift virtualization. So we may see, for example, VMware on-premises moving towards OpenShift virtualization, and likewise we could see something similar where we have doesn't have to be VMware, it could be VMware, it could be KVM, could be Hyper-V by Microsoft, any virtualization stack. But we could see those customers wanting to consolidate that, and in this case we would end up with that on managed OpenShift with virtualization. So a couple of things, as I said, we're going to see that migration from OpenShift 3 to 4. We're going to see migration from on-premises or some other environment into AWS. We potentially could see self-managed customers taking the move to managed. We could see existing ROSA customers adopting the new hosted control plane platform. And then, of course, we see these migrations from other application platforms to OpenShift, or consolidation of virtualization stacks into something like OpenShift virtualization. One question that comes up quite frequently is, if I'm moving from all of these platforms or these situations, is there something that can help me make that transition? Red Hat has several upstream open source projects under the Conveyor family that facilitate different parts of these migrations. They've packaged these up as migration toolkits that are available to be deployed through the operator hub in OpenShift. One of these is familiar to a lot of people who are going through migrations, and that is the migration toolkit for containers. Migration toolkit for containers, you install it on OpenShift, you connect to a source OpenShift environment, a destination OpenShift environment, and it can then pull the configuration from the source and then actually migrate the application workloads, the persistent volumes, the configurations from one OpenShift environment to another. So great tool whether you are doing OpenShift 3 to 4, whether you're coming from a different environment to AWS, or even if you're making one of these transition steps from self-managed to managed, or from managed to a hosted control plane platform. So migration toolkit for containers, it's going to migrate from OpenShift to OpenShift. It's migrating containerized workloads. The Tanzu situation's a little bit different. With Tanzu, we're not going to migrate the workloads that are running on Tanzu. What Tanzu tends to do in the background, this is the older Pivotal Cloud Foundry type workloads where developers would write code, put them into a source code repository, and the build pipeline automation within Tanzu would take that source code as is and then build it as a container. It's a little bit different. The developers themselves are not building the containers. So in that regard, we're actually going to work backwards from the raw developer source code, which potentially would be living in Git or some source code repository. So we would have a Git repository sitting in here with my application code. And what we would do is we would have the migration toolkit for applications. Again, this is installed on my OpenShift environment through the operator hub, and migration toolkit for containers is going to pull from the application source code and then help us containerize those workloads. So this is very much a modernization approach as opposed to a migration approach. We're modernizing those workloads and in the process putting them onto OpenShift. For virtualization stacks, again, we've got a toolkit that we can deploy in the environment, and that toolkit has the ability to connect to a source virtualization environment, in this example, VMware. So we can connect to VMware and we can move the virtual machines, the disk subsystems, and actually import them into OpenShift virtualization. So we have the migration toolkit for virtualization, and over here, migration toolkit for virtualization. As you can see, there's a lot of different migration mechanisms happening, some of them happening in parallel, some of them happening in series. We see a lot of organizational change management happening in the background, and what we have is we have these toolkits available from Red Hat that can be installed from the OpenShift operator hub and connecting to those source environments and pulling those configurations in. The migration toolkits are not magical silver bullets. They don't solve every single problem. The goal with the migration toolkits is to take the 80% of things that can be migrated with relative ease and help customers pull those in so that they can focus on the 20% where there may need to be some sort of refactoring. There are many approaches to migrating workloads. The concept behind Red Hat's open source conveyor project and these toolkits is, how do we take a toolkit and provide customers with a guardrail mechanism so that we can identify where the customer has done things that are going to be detrimental? Has the customer hard-coded things? Has the customer created dependencies that they haven't documented or aren't aware of? How do we detect those in the toolkits before we start the migration? How do we compensate for those? It's those unforeseen pitfalls that customers trip over and that drag out or hinder migrations. I hope this has been informative, just looking at the different migration permutations and then of course some of the toolkits available from Red Hat in these different contexts. Thank you for joining us.